this lesson, we're going to talk about how we're going to apply the laws of exponents to scientific notation. So scientific notation is probably a concept that you've learned in the past, and this is a way that scientists easily handle very large numbers or very small numbers. So I have some examples here in red and in orange. You can see that the red number is a very, very large number. You can see that the orange number is a very, very small number. And both of those numbers are rewritten into scientific notation. And it's a much easier, kind of like a shorthand way of writing a number like this. The original number is in something called standard form. And so we can actually transfer numbers from standard form into scientific notation, and then scientific notation into standard form. And this is probably something that you've learned in the past. So let's go ahead and review that concept before we get into how to apply the laws of exponents. So the key thing to remember here as well, and I have it indicated up here, is that when you have a number that's in scientific notation that has a positive exponent, you see it up here, that means that the number is going to be a very large number. And then when you have an exponent that is a negative number, that means that it's a very, very small number. So two things that are pretty important whenever you're transferring. So let's go ahead and try these first two. Transfer the number from standard form into scientific notation. So you can see here that I have two numbers that are both in standard form. And let's look at this first one. You can see it's a very large number. And what I mean by that is, ask yourself, would you want that amount of money put into your bank account? And I would say absolutely yes. So this is a very large number. So I know that my answer is going to have a positive exponent. So here's how you actually get the numbers. So I'm going to go ahead and put a decimal point at the very end of the problem. And if there's a decimal point already embedded in the problem, you can just use that to be your starting point. I'm going to move my decimal point all the way over to the other side between the 6 and the 2, right here. And because with scientific notation, I can only have one digit, which is the 6 here, to the left of the decimal. One digit. So that means it can be a number between 1 and 9. It can't be 10 because that's two digits. So it has to be 1 through 9. So let's go ahead and move my decimal. I'm going to move it 1. Oh, I lost my pen here. Let me grab my pen. 1, 2, 3, 4, 5, 6, 7. Notice how I'm counting the spaces. I'm not counting the zeros. I'm counting the spaces. That was 7 spaces. So I'm going to rewrite my number as 6.23 times 10 to the positive 7. And you're done. You move from standard form into scientific notation. Now let's look at a little number. This next one's a little number. And I know that because my decimal is in a different position here. I actually have a decimal in the problem. I'm still going to try to get the decimal so that there's one digit to the left. So I want to move it right here. So I'm going to move it 1, 2, 3, 4 spaces. So that's going to give me a new base number of 5.08. I'm always going to do times 10 to the, well, because it's a little number, I'm going to say to the negative 4th. Another way you could also say it is if you're moving your decimal to the left, you have a positive exponent. If you're moving it to the right, you have a negative exponent. And let's go ahead and do it the other way. Let's go ahead and transfer it from scientific to standard. Again, this is just a review of what you've learned in the past. So here I have a large number, and I know that because of my exponent of 5. So what I'm going to do is I'm going to go ahead and I'm going to rewrite my base number. And because I'm making this a large number, I'm going to move the decimal to the right so that I can make it a large number. So I'm going to move it 1, 2, 3, 4, 5. And I'm going to fill in all these empty spaces with a placeholder of 0. And that's it. That's my number. But I'm always going to rewrite it just so I know actually what the number is with all those little loop-de-loops. So I'm going to go ahead and write that down, put my commas, and there's your answer. And I'll do one with a small number. So here I have a number 7.03. That's my base number. and my exponent's -3. So I'm going to move it 1, 2, 3 spaces to the left and fill in those little loop-de-loops. And so that my new number in standard form is going to be this. Again, small number. They should match up to the exponent. All right. Okay, that was a review on scientific notation. Now let's go ahead and apply the laws of exponents using this skill of scientific notation. So let's go ahead and take a look at these 6 examples, and that's it. So this first one, actually the first 2 examples, what I'm going to be using is the product rule. Remember the product rule? That's one of the laws of exponents, and I'm going to go ahead and work this problem. So what I want to do is when I have a situation where I'm multiplying 2 numbers that are in scientific notation, I'm going to start with the base number. So use your calculator or use Desmos to go ahead and multiply 1.4 times 4.3. And that's going to give me a number of 6.02. And of course, I'm going to go ahead and put the times in there because I want to figure out what the scientific notation is. But you have to remember back to the product rule. When you have like bases and you're multiplying, you're going to add the exponents. So you can see here that my base number is 10. And I know that I'm multiplying because of the parentheses here. So I'm going to add those exponents, 4 plus 7. That's going to give me 10 to the 7th power. And I'm finished. That's my answer. See how I wrote it in scientific notation? Now you could take it a step further and write this into standard form, but we're not going to do that today. All right, let's try another one. This one is slightly different. I'm still going to be applying that product rule, but it's just slightly different. I am going to begin by multiplying our base numbers, 8.29 times 2. So go ahead and do that. And you're going to see that I'm going to end up with an answer that says 16.58. And I'm going to multiply that by, see what my exponent is. So I have like bases, right? That's my 10. And I'm multiplying, so I'm going to add the exponents, right? And that's going to give me 10 to the -3. Now, there's a little problem here. And the problem is that this number, it might look like it's in scientific notation, but it's actually not. And the reason is, look at, let me change my pen color here. Look at that number here. Do you see how there are 2 digits to the left of the decimal? You can't have that. So you actually have to do one more step to make sure that you get it into scientific notation. So I actually have to move that decimal 1 space this way, leaving me with 1.658. Do you see that? And if I do that, watch what I'm going to have to do. If I move the decimal to the left, I actually have to take my exponent and I have to bump it 1 space to the right, leaving me with 10 to the -2. So you have to do 2 little things there. You have to change the decimal, and then you've got to change the exponent to give you your answer. We'll do a couple more like this in a moment. Okay, let's go ahead and look at this one. This one obviously is going to be applying the quotient rule because it's a quotient. So we're going to do it the same way. Let's go ahead and start with our bases. I'm going to start with 5.4 divided by 5, and that is done right in your calculator. So that leaves me with 1.08. And of course, I'm going to multiply it by, well, let's figure out what the exponent is. My base is 10, which is a like, and I'm going to subtract the exponents, but be careful. This is 2 minus -3, right? 2 minus -3 leaves me with 5. So it's going to be times 10 to the 5th power. And this number is in scientific notation because we have 1 digit to the left of the decimal. So we're done. Pretty easy. Once you get the hang of it here. Let's try another one. This one you're going to have to move that decimal again. So let's take our base number. So 5.1 divided by 6. Let's start there. 5.1 divided by 6 is going to leave me with 0.85 times, now look at my tens. That's where we're going to go next. I have to use my quotient rule. So -5 minus negative 3. See that? Negative 5 minus negative 3 is really adding 3. So that's going to give us 10 to the negative 2. But there's a problem here. Do you see the problem? Do you see how my decimal is in the wrong place? This time I'm going to move my decimal one space to the right. If I do that, that means I have to take my exponent and I need to move it one space to the left. And that's going to leave me with 8.5 times 10 to the negative 3. My rule of thumb with the exponents, if you're moving, let me go ahead and I'll write it up here at the top. If you're moving your decimal to the right, you're going to move your exponent to the left. Do you see that? If you're moving your, let's say if you're moving your decimal to the left, you're going to move your exponent to the right. So you're either going kind of together or apart. All right, I've got 2 more examples here for you today. And this one's going to be using the power rule. So we're going to treat it just like we have been. So let's take our base number of 1.4 and let's raise it to the 6th power. And this is all in the calculator. Now it's going to give you this big ugly number like 7.529536. Just go ahead and gather up just a couple numbers. I'm going to go ahead and say we'll just say 5, I'll just do 5.3. How about that? We'll just round it to the hundredths place. And that's perfectly fine in this situation. Okay, now let's go ahead and use our power rule. So we have 10 raised to the 3rd raised to the 6th. So I'm going to multiply those to give me 10 to the 18th power. And that's it. We're in scientific notation. My decimal's in the right place, and we're all done. All right, last one here. Let's go ahead and try this one. This one's a little bit of a strange one. So 8 raised to the negative 2. I know you might want to use that little trick with your exponent rule here where you move it to the denominator, but just remember, we're using scientific notation. So it doesn't really apply. It's a different concept. So 8 to the negative 2 is going to leave us with this number, 0.0, looks like 1, let's just do 156. I think that's enough for today. And then it's going to be times, and then I'm going to use my power rule, so 10 to the 12th power. Obviously, not in scientific notation, right? I've actually got to move it 2 spaces. Do you see that? I got to move it 2 spaces to the right. That means I need to move my exponents 2 spaces to the left, leaving me with 1.56 times 10 to the 10th power because I subtracted 2 and I'm all done. So that's how we apply the the laws of exponents to scientific notation. That brings us to the end of the lesson today.